Okay, let's wrap up learning target 2. So, we have someone on an elevator and it's motionless. Okay, so we don't have any velocity or acceleration. So that would mean that our force due to gravity is going to equal that normal force. And so my net force would be 0 newtons. Okay, so since I am not since I'm not falling, right? Because they're not falling through the ground. That'd be 0. The net force is 0. The force normal would equal the force due to gravity. Okay, and then force due to gravity. This is an equation that just simply says the force due to gravity is going to equal the mass of the object multiplied by the acceleration due to gravity. So the mass of the object is 100 kilograms, and then you'll multiply that 100 by the acceleration of gravity. So we'd have negative, let's see, 9.81, so 981 newtons. Okay, so that's our force due to gravity there. And then our force normal would be equal and opposite from that. So that'd be 981 newtons. Okay, now our net force when we have an acceleration, which is 2 meters per second squared. Okay, well, we know that net force is equal to mass, which is 100 kilograms, multiplied by the acceleration, so 2.0 meters per second squared. So our net force is going to be 200 newtons. And so again, we have a force due to gravity, and then we have an even larger force normal. Okay, and we know what that sum is. So we know that the sum of the two forces has to equal 200 newtons. And we have a negative force due to gravity, which is the same as before. I mean, the mass of the object didn't change. So that force due to gravity would be negative 981. And so we're taking our normal force, which is what we're solving for. We'll just call it force normal. And then we're going to be subtracting or adding a negative 981 newtons. Okay, so if I add that to the other side, that means my normal force, let's see, so it'd be 1,181 newtons. Okay. Our net force is our force normal added to our force due to gravity, which was negative, and we've already kind of said what that net is, and we said what the normal is. Okay, here we have a constant velocity, but we don't have an acceleration. So this force is equal to mass, and I should say sum of the force, or that net force, mass times by acceleration, but acceleration is 0. So here, 0 multiplied by anything is 0. So our net force is 0 newtons, okay, because I'm not accelerating. And so the normal force is going to equal the force due to gravity. So that's going to equal the force due to gravity. The force due to gravity is negative 981 newtons. Okay, and this is magnitude-wise, and so it'd be 981 newtons. Because when we add those together, we should get 0. Okay, and so now we have a negative acceleration. Okay, so we're going to take some of the forces as mass times by the negative acceleration. Okay, So we'd have mass multiplied by that negative acceleration. So our overall net is negative 200 newtons. Okay. And our force due to gravity is always the same. The mass doesn't change, the acceleration due to gravity doesn't change. So this sum here, this negative 200 newtons, that's going to be the force due to gravity added to our force normal, because that's the only sums that are being involved here. So that would be force normal plus the negative 981 newtons. So if we add that to the other side, our normal, let's see, nice, it'd be 781 newtons. Okay. Okay, so I want you to take some time to think through this, give this a go, and then this just kind of talks about what we've been discussing. And so that's it for learning target number 2. I wanted to go over a couple practice problems here. Okay, so let's just quickly look at those. They don't take very long. Let's look at, let's just start with number 2. Jared is learning how to skate. He wants his wife to pull him along so that he's accelerating at that rate. If Jared's mass is 27.2 kilograms, with what force does his wife need to pull him? Neglect any air resistance. So acceleration is 0.80 meters per second squared. Mass is 27.2 kilograms. And we want to know force. Okay? Force is going to equal mass times by acceleration. So force is going to be mass, 27.2 kilograms, multiplied by acceleration. So that would be 27.2 multiplied by 0.8. 21, we have 2 sig figs, 3 sig figs, we'll do 2 sig figs. So it'd be 22 newtons, which is a kilogram meter per second squared. Okay. You're exercising and need to lift a 35 kilogram dumbbell. If you exert an upward force of 502 newtons on the weight, what is the dumbbell's acceleration? So we know that force is 502 newtons, and we know that the mass is 35 kilograms, and that the acceleration is what we're solving for. So force is equal to mass times acceleration. So it's divide by mass to get acceleration by itself. So acceleration is equal to force divided by mass, so that would be 502 newtons divided by 35 kilograms. We have 3 sig figs, 3 sig figs, so our answer is going to be 3 sig figs. So Isaac and Yoda are fighting over Molly again. Molly has a mass of 0.30 kilogram. Isaac is trying to pull Molly away from Yoda. If Isaac pulls horizontally on Molly with a force of 10 newtons and Yoda pulls horizontally with a force of 11 newtons, what is Molly's horizontal acceleration? So here's Molly. We have Isaac pulling her. Actually, we'll have Isaac be this direction. We have Isaac pulling with 10 newtons, and we have Yoda pulling with 11 newtons. So the sum of my forces in the x direction is going to be a positive 11 newtons plus a negative 10 newtons. So that overall sum of the force is going to be 1 newton. Okay. And let's see, that was 3 sig figs, that was 3 sig figs. So let's make this 1.00 newtons. Okay. Now, we know the force. That's equal to the force. We know the mass, 0.30 kilograms. We want to know the acceleration. So we have already rearranged this equation to solve for acceleration. So acceleration is equal to force divided by mass. So force is 1 Newton divided by 0.30 kilograms. 3 sig figs, 2 sig figs. So my answer will be 2 sig figs, 3.3 meters per second squared. A force of 50 newtons provides a constant acceleration across a frictionless horizontal surface to a 25 kilogram crate originally at rest. How many meters does the crate move in 3 seconds? Okay, so one more time, a force. So force is going to equal 50 newtons. Provides a constant acceleration across a frictionless horizontal surface to a mass that is 25 kilograms. Let's figure out what that acceleration is. Okay, so acceleration is force divided by mass. Force is 50 newtons. Mass is 25 kilograms. Okay. So that would be 50 divided by 25. 2.00 acceleration, meters per second squared. Okay, so that's the acceleration of the object. And so we have this crate, and it's sliding across this frictionless surface. And the crate is moving for 3 seconds. So let's make this our 0 position. Okay? So position initial is going to be 0. Position final, that's what we're solving for. Velocity initial is 0 because it said it started from rest. Originally at rest. Velocity final, we don't know what that is. We do know what the acceleration is, which is 2 meters per second. Time initial is 0. Time final is 3 seconds. Okay, so we need to choose an equation that does not have velocity final, and we want to know what x final is. So that one's not going to work. That one's not going to work. That one's not going to work, but this one does. X final is equal to x initial plus velocity initial t final plus 1/2 acceleration t final squared. Well, our initial position is 0. Our initial velocity is 0. So x final is equal to 1/2 acceleration t final squared. So 1/2 times by 2 meters per second squared times by 3 seconds squared. So I'm going to plug that in. I get, let's see, that was 1 sig fig, so I get 9 meters. Okay. That's going to wrap up learning target number 2.